So let's start with, by the way, this is partial, okay. This is partial fractions. Okay, let's start with a very simple example. So, example 1. Let's try to integrate dx over 1 minus x times 1 minus 2x. Okay, so we know that we have to use partial fractions here because if you look at it, there's no other way of solving this. Like the other techniques cannot be used for this one. You can use use substitution. You can use any of the other techniques. So in this case, you can see that the denominator is already in factored form. So this is easier now. You will just separate like the two factors. So you're gonna create two integrals. So a over 1 minus x using each of the factors plus b 1 minus 2x. Put the dx there, put the dx. Okay, so what we do now is get the LCD, like the LCD of these two fractions, a over 1 minus x and b over 1 minus 2x. So I get the LCD. I will have like a 1 minus 2x plus b 1 minus x all over 1 minus x 1 minus 2x. Okay, the other side will just be 1 over 1 minus x 1 minus 2x. Okay, you might say, oh, why did the integral signs disappear, the symbols disappear? It's because it's easier to deal like instead of like writing it every single time. So we're just gonna write it at the end when we get the a and the b, the values of a and the b. Okay, so at this step we were just combining these two fractions on the right and multiplying each one by the other factor so that we will have the common factor a minus x and a minus 2x. This is LCD. Okay, now if you observe the left and the right fractions, they have the same denominators, right? So if they have the same denominators, then we're gonna say, oh, if both denominators are the same, then that means both numerators are also the same, right? Because we can always multiply both sides by that LCD. So this becomes 1 equals a 1 minus 2x plus b 1 minus x. And then on this next step, we have two choices. We can use systems of equations, but it's the long way. So I'm just gonna introduce to you the shortcut. Okay, this is the shortcut, and this is what I taught in the class too. So think, what will make what will make the denominators 0? Look at the denominator. There are two factors, right? So what are the two values of x which will make the 0? Okay, so think about it here. The first one, 1 minus x equals 0. For that to be 0, x must be equal to 1, right? Right? And for the second one, 1 minus 2x equals 0, 1 equals 2x. For it to become 0, x must be 1/2, right? So these are the two values that will make the denominator 0. We're gonna use these two values now to find the values of a and b, the variables a and b. So first, we use the first value, which is x equals 1. So when x equals 1, our equation becomes 1 equals, okay, when x equals 1, plugging in 1 here, I'm going to have 1 minus 2, which is negative 1, right? Right. And if I plug in 1 on this part here, I know that this is going to become 0, so the b disappears. B basically disappears. Okay, so with this now, with this equation now, I know that negative 1 will be the value of a when we divide both sides by negative 1, right? Now, for the second value of x that will make the denominator 0, I'm now going to plug it in. So my equation is 1 equals, okay, plugging it into the 1 minus 2x on this part, plugging in 1/2 there becomes 1 minus 1, so the a basically disappears. Now let's plug it in here on the b. Okay, so after we plug it in here, we know that that becomes 0, so let's plug it into the b. When I plug it into the b part, this becomes 1 minus 1/2, and that becomes negative 1/2. Oh, no, 1 minus 1/2 is 1/2, right? So this will become 1/2, or b times 1/2. Now to solve for b, I multiply both sides by 2, so that gives me 2 equals b. So now I have my values for a and b. I am now going to put in those values in the very first equation where I separated the integral into two separate integrals, right? This part here, this part here. Okay, so I'm gonna plug it in there. Let's say, so my a is negative 1. Let me see. So that's going to be negative 1 over 1 minus x. And then the b is 2, so that's a 2 over 1 minus 2x. Right? And you still have the dx, you still have the dx. Okay, so I'm going to go to the next page now so we can do the integration. So my right side will now become, after we put in the values of a and b, so we have negative 1 over 1 minus x, right, dx, plus positive 2 over 1 minus 2x. Okay. Using u substitution, we can now solve this. So with u substitution, I'm going to go u equals 1 minus x, du equals negative 1 dx, and I have a negative 1 dx, so this becomes du over u, right? Now on the other side, if my u is 1 minus 2x, my du is negative 2 dx, so negative du equals 2 dx, and I see the 2 dx there, right? So this becomes negative du over u. Okay, now the integral of du over u is ln u. We know that, right? That's one of the integrals that I told you to at least memorize or put in your mind, right? Because 1 over u is the derivative of ln u, so naturally the integral of 1 over u is ln u, and then this one will be negative ln u. But they have different u's though, so we put them back to whatever their u's are. This will be ln of 1 minus x, and this will be ln of 1 minus 2x. Then put plus c. Now, sometimes they would leave the answer like this, or they might use the property of logs, which is log A minus log B equals log A over B. I don't know if you can still remember that, but that's the second law of logarithms. So, which is the same as the natural log law. So, if we use that property, this will be ln of 1 minus x over 1 minus 2x plus c. And that's the answer right there. Okay? Now, let's have one more example. Okay, this time my problem looks like this. The integral of 2x plus 16 over x plus 3 Oh, you know what we can do? We can use the problem that you showed me, the problem from the circuit. The problem from the circuit that you showed me. So we can use those problems. Let's do this one. Let's do this one. Okay, what happened? Okay, so this was 3 to 4 of a minus 9 over a plus 5 a minus 2. Okay, we're going to be using partial fractions in this, partial fractions, because you cannot use any other. If you try like use substitution here, you can't. So what we do is separate, right? So that the left side will be a minus 9 over a plus 5 a minus 2, and then we separate this into two fractions. So a over a plus 5 plus b over a minus 2. This is dA. Okay? And then we do the same thing as what we did. A minus 9. I'm not going to write the LCD anymore because anyway they're going to cancel, right? So this is a minus 2. Okay? Multiply it with the other factor plus b, a plus 5. Okay? Okay, cancel the denominators. And then we think, what are the values of a that will make our denominator 0? We have a equals positive 2 and a equals negative 5, right? Okay, so let's plug it in one by one. So when a equals 2, let's see what happens to the equation. Our equation becomes 2 minus 9, right, equals, okay, when I plug in 2 here, the a disappears. When I plug in 2 to the b, that becomes 7b, right? And so this turns negative 7 equals 7b, which gives us b equals negative 1. So we now have the b. Now, when a equals negative 5, let's see what happens. Negative 5 minus 9 equals, okay, when I plug in negative 5 to the a here, over here, negative 5 minus 2 is negative 7a, right? When I plug in negative 5 over here, that becomes 0, so the b disappears, the big P disappears. Okay, so this becomes negative 14 equals negative 7a, and so our a is positive 2. Okay, all right, it's positive 2. So again, we follow the same procedure. We are now going to plug it back in. So our a was 2. This is 2 over a plus 5 dA. And since b is negative, so I'm going to make this minus 1 dA over a minus 2. Okay, and then we integrate. This will be 2 ln a plus 5. You already know that that's ln, right? Minus ln a minus 2 plus c. Okay, and then you can again apply the second law of logarithms or ln's, and this might look like this. Ln a plus 5 squared over a minus 2, because that 2, this 2 here, by applying the third property, becomes the exponent of the a plus 5 and then plus c. I don't know if that's how it would look like in the answers in the circuit. Try to see if there's an answer that looks like that in the circuit. Okay, so let's see if you understand my examples.